board thing. That would be kind of important. Oh, sharing the board. I have now, you can see the board. Miss Flynn, can you see the board? Yeah. All right. Let's get this started. So number 3, I have xy equals 4. And so dy dt they give me as, well, that's what I want to know. When x equals 8 and dx dt is equal to 10. I recognize I need an equation. Since they gave me one, I'll go ahead and use the one they gave me, which is awful nice of them. That's a 4. So now I go, it's two things multiplied together, so I have to do the product rule. So I'm going to go x times 1y prime plus, oh, I should do dy dt. That was almost lazy. So dy dt plus dx dt times just plain old y equals 0, because derivative of 4 is 0. I plug in what I know, which is x is 8, dy dt is what I'm looking for, plus dx dt is 10 times y. I'm missing y. I need y. So to figure that out, what I'm going to do is just plug in my 8 right here to figure out what y must be to make that work. So that's going to be 8 times y equals 4. Y must equal 1/2, so I'll put a 1/2 right here. And so that's going to give me an 8 dy dt plus 5 equals 0. Dy dt, 8 dy dt equals -5, or dy dt equals -5/8. Is that okay, everybody? Questions, concerns, thoughts? That should have hopefully felt easy, although you might have made a mistake like on the product rule or something like that. Anything? All right, let's get started. Go ahead and do number 5, and then number 7, then number 9. Number 9 is going to stop you. I'm going to write some answers on the board as I go. I might call on some people just to see if you're paying attention. But look at 5, 7, and then 9 is going to be hard and weird. It's actually really easy, but you have to read it with your head in the right place. So it's probably going to stumper. Okay, try 5, 7. Both the answers. All right, cosine of -pi/3. Cosine of -pi/3 would normally be 1/2. It's in the 4th quadrant, so it's going to be positive as well. And so it'd be 1/2 on the bottom squared times 2. Flip. Now let's check. Actually, just do it. It's 1/4 times 2. I'll probably do this the world's hardest way. Flip and multiply. I get 1 times 4/1 times 2, which is, I believe, just 8. Mr. Davila, are you there?
Yes.
I had a conversation with your counselor. I think we can figure out a way to do that, but you're going to have to give me a little bit more time to figure it out, okay?
What am I doing?
Tomorrow you're coming in for sure for
No, I
physics.
don't want to do that.
You don't want to do that?
No.
Well, then you don't come in.
Decision made behind my back.
I'll go. Well, okay. So wait a second. Who wants you? Like, is this a parent thing?
My mother thought she wanted me to come in, but no, I do not want that. At least not right now.
Okay. All right. So, okay. I will try to handle that in a less public way. Got it.
Sorry.
Yeah. What am I going to do here?
So I looked at the graph.
Uh-huh.
And so the first one says, given that dx dt is negative, so that would mean that it would be going, the slope, the x slope would be going in the negative direction, right? So you'd be going left on the graph.
Okay, so I'm going to change your words just a smidge. I'm going to say the following. I'm going to say, look, my x is changing with respect to time, in the negative direction, which means I'm going to the left, just like you said, right? I'm going to be going this way. If I'm going to the left on my graph, what is happening with dy dt?
It's going up.
It's going up. So is it positive or negative? So it's positive. What? Mr. Reber, good pick, man. He nailed it. He nailed it. Mr. Reber, does that make sense, though?
Yeah.
All right, with that in mind, you got the second one. If dy dt is positive, what must be true about dx dt?
That's negative
How do you figure that?
because when dy dt is positive, it's going up.
If I'm going
So-
uphill, I have to go in the negative x direction. Weird, huh? Good, Mr. Reber?
Yeah.
Anybody else need a little more time with this one?
Can you clarify part B real quick?
Part B? Okay, so what it says here is if dy dt is positive, that means I got to be going up in the y direction. So let's pick a spot in the graph. Here, I'm picking this spot right here. Which way am I going uphill for the y direction? Which way are we going up in the y direction as time goes on? It'd be this way, right?
Yeah.
Which means I have to be going in the negative x direction, don't I?
Yeah.
Which is what to do. So dx dt must be negative.
Okay, makes sense. Thank you.
It makes sense. It's just kind of, it's so, simple is the wrong word, but simple. It's so rudimentary, like takes a little thinking to get your head around it. For the very first time I read this problem, I read it like 4 times going, what? Feels good though, right? You got it?
Yeah, got it.
All right. We're going to do 11 now. We're going to see if Mr. Perel's getting a sandwich right now.
No, I do that during physics resting.
Good morning, sir.
Good morning.
All right, Mr. Paulos. Ready for this one?
Yes.
Excellent. All right, so I have considered the linear function y equals ax plus b. It says linear function that gives us y equals ax plus b. It's a little redundant, don't you think?
Yeah.
How do I know that y equals ax plus b would be linear?
There's no squared or nothing to the power.
Perfect. That's excellent. So if x changes at a constant rate, does y change at a constant rate? Well, we're talking about changing, right? So how do I do the changing? How do I turn this into a changing equation?
I don't understand.
Well, it's saying that that's a rate. Doesn't it mean that's a rate with respect to time? If I want to know how fast y is changing with respect to time, what must I do to this?
Take the derivative.
With respect to time, right?
Yeah.
What we're doing right now. So do it for me.
Would that just be 1 with 1 dy over dt equals
A is a number in this context. We're going to leave it alone.
So then would we put 1 in place of x, so a, or no,
The
0.
derivative of 2x would be 2, right?
Yeah.
And that's attack on the chain, right? So what's the chain?
was be 1.
Well, when I'm taking respect to time, aren't I?
Oh yeah, so dx over dt.
Dx dt. And then b is just some number. So what happens when I take the derivative of a number?
It'd be 0.
Goes away, right? So this is the situation. So cleaned up, I get dy dt equals a dx dt. So here we go. Question number 1. If x changes at a constant rate, that means they're talking about this derivative, right?
Yeah.
If that is a constant, would y be a constant? Would dy dt be a constant?
Yes.
Yes. Absolutely, right? Because a is just some number, so some number times dx dt would be the rate. Second question. If so, does y change? Sorry, we did that already. If so, does it change at the same rate? Does dy dt change the same rate as dx dt?
No.
Why not?
There's other things that are
Right.
affecting the x.
If this was a 3 and this was a 2, say, dx dt would be 2, dy dt would be 6, right? So they would be different rates. They'd both be a constant rate, but they would be different.
Yeah.
Okay. Weird problem again. So kind of fundamental that it's not that bad, but it's also kind of weird. All right. Now do I play the game of? We're going to skip 13 temporarily on the back and go right to 15. Skip 13 and go right to 15. 13 is fun, and we'll deal with that in just a moment. Let's do 15 first. Get our feet wet.